Alright, in this video I'm going to do the homework for the average value theorem. So since you guys are not in school, I wanted you to be able to do the homework and I wanted you to have a video to be able to check your work. So let's start by reviewing the average value theorem that you looked at in the video from the day before. Remember, the average value of the function, it starts out as a definite integral, which we did before exams. So it's the area under the curve of f of x. So there's our function that we're finding the area under, and we're going from a to b. Now all we're doing, remember, an average, you add up all of the stuff and you divide by the amount of stuff, so to speak. So when we do an average, we're finding a sum, and that's what the definite integral does. Sorry about that. Oh, by the way, I'm using a slate to record this video, so sometimes the pen gets a little crazy and it does things that it wants to do. So bear with me on that. So if the writing is not as good as it could be, that's what's going on. So anyway, we're finding an average, and an integral, remember, looks like the letter S, and so that's what accumulates or sums up the area under the curve. And then we're going to take that accumulation and we're going to divide by the interval itself. So that's where that whole idea of averaging comes from. Remember, when you find the antiderivative of little f, big F comes back, and by the fundamental theorem of calculus, we evaluate at the upper bound minus evaluate at the lower bound, and then the averaging is where we're dividing by the number of stuff. So that is the average value formula that you looked at in yesterday's video. Alright, so your assignment is 328, 57 through 63, and 67 to 62. I'm not going to do every one of these, but I'm going to do several of them so you can figure out if you're doing the work okay. And then I'm going to show you a geometric representation. Notice over on the right hand side of the graph, you see the graph of the integrand, which is 4 minus x squared. Let me actually erase that. And I'm going to show you, after I do this analytically, I'm going to show you graphically what's going on. Alright, so let's start with the first problem, number 57. We're finding the average value of 4 minus x squared from negative 2 to 2. So our formula says that we're going to do 1 over, let me get my pen, sorry about that. Alright, now I got my pen. So we're going to do 1 over b minus a, so 2 minus negative 2. And the integral is from negative 2 to 2 of 4 minus x squared dx. Alright, so when we do 1 over 2 minus negative 2, we get 1/4. And then I'm going to find and there's the pen doing kind of some funky things, so let's get rid of that. And get the pen again. Alright, so we're going to find the antiderivative of 4, which is 4x minus x cubed over 3. And again, we're going from negative 2 to 2. So we have 1/4 of, I'm going to substitute in the upper bound of 2. So 4 times 2 is 8. Minus 2 cubed is 8, so that's 8 over 3. And then the lower bound, remember the fundamental theorem of calculus. Again, I'm sorry about this pen and this slate. So when we substitute the lower bound, 4 times negative 2 is negative 8. And then negative 2 cubed is negative 8 over 3, and then I have a positive 8 plus another 8, so we have 1/4 of 16. Then I have negative 8/3. This is a positive, so negative 8/3 minus 8/3 is negative 16/3. And that's going to give me 1/4 of 16 is 48/3 minus Now this is really going to bug me if it's going to keep doing that. Minus, minus 16/3, which is 1/4. 48 minus 16 is 32 over 3, and so then we multiply and we get 8 over 3. So 8 over 3 is 2 2/3. That's the average value. Now remember, the average value is a y value. So if I come over here to this graph and I go up 2 2/3, which is about right there, and I go over, and I'm going from -2, this is kind of ugly, but bear with me, to 2. The area that is inside of that rectangle is equal to the area under the curve from -2 to 2. So that's basically what's going on with the average value. Now the 2 2/3 is the average value, that's the y value. If I wanted to find the mean value, and I don't remember if they asked us to do that in this problem or not, but I would take the 8/3, which is the y value, and I would set that equal to the function, and the function is 4 minus x squared. Sorry guys about this pen. 4 minus x squared, and I would solve that equation, and whatever I get for x, and I would get two values of x, because see, there's a y value here on the graph and a y value here. So each of those y values has an x value. The x value is the mean values. So that would be equal to the mean value. And this is the, I think I'm holding this, not holding this thing well or something, the average value. Okay, let's take a look at the next one. Hopefully you can kind of follow this. It looks kind of sloppy, but I'm doing the best I can with the Promethean pen and the slate. Alright, the next problem, we're going to find the average value. Remember, the average value is 1 over b minus a, so that would be 1. Alright, come on, we can do this. That would be 1 over 3 minus 1, and we would go from 1 to 3. Now notice what I'm going to do with the function. I'm going to distribute the numerator and get 4x squared plus 4 over x squared dx. Still cleaning, so that's 1 over 2 from 1 to 3. I'm going to divide each term by x squared, so that would give me 4 plus 4x to the -2 dx. So that is 1/2. And finding the antiderivative of 4 gives me 4x. Finding the antiderivative of 4x to the -2, if I increase the power by 1, I'll get 4x to the -1 divided by -1 would make that minus from 1 to 3, which is 1/2 of, I'm going to put in the upper bound of 3, so 4 times 3 is 12, minus, now that x to the -1 is going to go to the denominator, so I'm going to make that 4/3, upper bound minus lower bound, so that would give me 4 minus 4 over 1, which is 4. Whoops, I see a mistake that I just made. I didn't put in let's see, am I putting in the lower bound? Yeah, I did. Okay, I did fine. So that would be lower bound, 4 times 1 is 4, minus 4 over 1, which is 4. Okay, we're good. I thought I made a mistake, but I don't think I did. Which would give me 1/2 of, if I change 12 into thirds, I get 36 thirds minus 4 thirds. And of course, 4 minus 4 is 0. So that's 1/2 of 36 minus 4 is 32 over 3. And that will give me an average value of 16 thirds. So that is the average value. All right, let's see if I can do a better job of kind of showing what that looks like. 16 thirds is 5 1/3. 5 1/3 is about here. Let's see if I can draw a line. Well, that's not too bad. The interval is from 1 to 3, so let's come from 1, okay, and to 3. So the area inside of this blue rectangle, I don't know how good of a job I can do of shading that, is equal to the area under the curve from 1 to 3. Now, let me change colors here. Let's go with this green. So the curve hits 1. Well, you can't even see. It's like way up here. So the area under the curve from 1 to 3 is equal to the area in the rectangle from 1 to 3. I don't know if that completely makes sense to you guys or not. Now this is the average value. It's the y value. That's 5 1/3 or 16 thirds. The mean value is what you get. It's the x value that produces, I don't know that it's 2, but I'm just somewhere in this vicinity is the mean value. The way that we would get that is we would take 16 thirds and we would set it equal to the original function f of x to see what x value is producing that y value. So the 5 thirds is the average value, and what we would get if we were to solve this equation would be the mean value. All right, let's go on to the next problem. Number 59, we have 2e to the x, so the average value is 1 over b minus a, so that's 1 minus -1. The integral from -1 to 1 of 2e to the x dx. That's the same thing as 1 over 2. I can go ahead and pull the 2 using my properties of integrals to the outside. -1 to 1 of e to the x dx, which is the same thing as if we multiply 2 times 1/2 of 2, we get 1. So, and the antiderivative of e to the x is e to the x from -1 to 1. So we're going to evaluate at the upper bound, which is e to the first, minus the lower bound, e to the -1, which is e minus 1 over e. If I get a common denominator of e, I'll get e squared minus 1. And if I were to approximate that decimal value, I could find that on my graph over here, the y value. This is the average value. Remember that it is a y value, and it is a y value that's located somewhere on this curve over here. And then to get the mean value, we would take the average value, e squared minus 1 over e, and set it equal to the function 2e to the x and solve, and that would give us the mean value. The x value is the mean value. The y value is the average value. So the x value, the mean value, is the input. The average value is the output. Number 60, 1 over 2x. So the average value formula is 1 over b minus a of a to b of the integrand dx. 1 over 4 minus 1 is 1/3. I'm going to use my properties of integrals to pull out the 1/2. And we're going to go from 1 to 4 of 1 over x dx. Remember that 1 over x, the antiderivative of 1 over x is ln, so we have 1/2 ln absolute value of x from 1 to 4, so that's 1/2 of upper bound ln of 4 minus ln of 1, so that's 1/2. The ln of 4 is a decimal value that I don't know. The ln of 1 is 0, so we have 1/2 ln of 4. Could change that into ln of 4. I don't think this is absolutely necessary, but it's a good idea to review that log property. So that would be ln of 4 to the 1/2, which would be ln of 2. That is the average value. Next one. I'm skipping 61 because it's a trig function. I'm just going to do one of the trig functions for you. And let me pull this graph over out of the way. Up here. Get the pen back. Alright. The average value, 1 over b minus a, so pi over 2 minus 0, from lower bound, 0, upper bound, pi over 2, cosine x dx, which is 1 over pi over 2 is 2 over pi, dividing fractions. The antiderivative of cosine is positive sign. Be careful there. Remember, when you're finding the antiderivative, here we go with my pen, want to be funny again. Remember, when you're finding the antiderivative of a trig function, and I'll do it in just a second if I can get this pen to work for me, 0 to pi over 2. The trick to, when you find the antiderivative of cosine, I got sine, so I'm going to take the derivative of sine and get cosine to make sure I did that correctly. So that's 2 over pi sine of pi over 2. Come on, pen, please stop doing that. Not fun making a video on this slate. Minus sine of 0, so that's 2 over pi. The sine of pi over 2, think of your circle, pi over 2 is up here, so it's the y value, so that's 1, and the sine of 0 is 0, so we get 2 over pi is our average value. Okay, so basically you've got to learn that formula. There are a couple more that I'm going to do for you here. Unfortunately, I don't have the problems for, what was it, 60, go back here. I don't have 62 and 63. It's an area under the curve problem. You should be able to use the solutions manual, which is still online for you to take a look at. I'm going to jump to 67 to 72. In this problem, according to the directions, the shaded area A, now mine does not look like it's shaded, I'll shade it in a little bit. Here's the shaded area A. That has an area of 1.5, and since that area is under the curve, I'm going to remember that that's negative, and let me change colors here. Orange is fine. The area from 0 to 6 is 3.5. So from here to here, the whole thing is 3.5. So 3.5 plus 1.5 would give me an area of 5 up here. Now again, remember, the area of B, which is 5, that's positive. 5 plus negative 1.5 gives me a total area, or a net area, a net area of 3.5. So that's how I know that B is going to be an area of 5. So the area from 0 to 2, area A is 0 to 2, so the area from 0 to 2 is negative 1.5, that is the net. For 68, the area from 2 to 6, that's 5, that's the positive area. Now notice in number 69 that they're taking the absolute value of the region, so they're going to force this negative 1.5 area region upward to be a positive 1.5. 5 and 1.5 gives me a total of 6.5 for the total area. Number 70, I can take the negative 2 out as a coefficient, and in other words, I can multiply it by the answer that I got from number 67. So negative 2 times negative 1.5 is 3. Using my properties of integrals for 71, I'm going to say that that's the area from 0 to 6 of 2 dx plus the area from 0 to 6 of f of x dx. Now we know that the area from 0 to 6 is 3.5. That was given. And then the area from 0 to 6 of 2 is 12, because remember that's a rectangle. It's going to be 6 units long from 0 to 6, and then it's going to be 1, 2 units high. So all we're really talking about is a rectangle that's 6 by 2 for an area of 12, and 12 plus 3.5 gives me 15.5 for a total area there. Alright, the average value from 0 to 6 would be 1 over b minus a from 0 to 6 of f of x dx. We already know that the area, they gave us from the beginning that the area from 0 to 6 is 3.5. So we have 1/6 of 3.5, which is 3.5 over 6, and we could simplify or reduce that. So that's the homework. Shouldn't be too hard for you. Again, make note of any questions that you have. We're going to clean everything up when we get back, but I do want you to be able to go ahead and move forward and practice this stuff.